Hello guys! In this lecture, we'll talk about hashes. You'll find them in many areas of computer science. Hashes are a critical part of password systems, digital signatures, security certificates, blockchain technology, cryptocurrencies like Bitcoin and Ethereum, or even how the supermarket POS verifies the PIN of your credit card when you want to pay for something. Let's dive deeper into hashes. A hashing algorithm is a cryptographic function that takes an input, runs it through some magical mathematical processes, and then creates a unique output called hash. The output hash is sometimes called message digest, checksum, or cryptographic fingerprint. The input of the hash function can be literally anything, from binary information like a file, a packet, a single character, to a word or a phrase. I'd like to show you a practical example using a Linux machine, since it already has all applications needed to calculate hashes. If you are using Windows, you need to install the required tools. So I'm executing SHA-256 sum etc password. Let's take a deeper look at the command xargument and xoutput. The hash function or the hash algorithm used is SHA-256. SHA stands for Secure Hash Algorithm, is pronounced SHA, and is in fact a family of more hash protocols. SHA-256 sum is the Linux application, the tool that implements the hash protocol, which, as I said, is SHA-256. etc password is the input of the hash function, and this string, written in hexadecimal or base 16, is the hash of the input. We can simply say that the SHA-256 hash of password file is this value, the value you are seeing right now. You should know that all hash algorithms are public. They are like a public math formula that anyone can see and use. For example, SHA-256 is part of a bigger family of hash algorithms called SHA-2. You can read more about them even on Wikipedia. Look, this is the pseudocode for SHA-256 algorithm. You can implement it in any programming language. It's public. Other well-known hash algorithms besides SHA-2 are MD5 and SHA-1, which are considered insecure and obsolete. Let's see the hash of Linux word calculated with MD5 and SHA-1. Echo minus n and the word Linux. You can write anything you want. Pipe MD5 sum. Minus n is used not to add a new line. By default, the echo command ends a new line at the end. I want to calculate the hash only of this word. And the hash calculated using SHA-1, that's the hash. They are written always in hexadecimal numbers. Other very secure and new hash algorithms are SHA-3 or Keccak, Blake2b, and RIPE-MD160. Blake2b is used by Ethereum 2.0, and RIPE-MD160 is one of the two hash functions used by Bitcoin, and they are never hacked. Another way to calculate a hash is using the OpenSSL command like this. OpenSSL digest from digest minus SHA-3 minus 256. This is the hash algorithm and the file, for example, etc password. Okay, This is the hash. This is different than this one because it's another hash algorithm used. Or you can calculate the hash of a string this way. Echo -n Linux, pipe, OpenSSL, digest, and the hash algorithm. For example, RIPE-MD 160. That's the hash. You can see a list of all hash algorithms implemented in OpenSSL by executing OpenSSL and then help. These are all hash algorithms implemented in OpenSSL. Let's try another example. Let's calculate the hash of Word Linux using this time SHA-512 algorithm in different ways. In the first example, I'll be using the SHA-512 sum command, like this. Pipe SHA-512 sum. This is the hash. Or using the OpenSSL command. This is the hash. I can also use an online tool to calculate the hash. I am selecting SHA-512 and the input Linux. And this is the hash. And we notice something very important. No matter how we calculate the hash, if we use the same algorithm, we get the same hash, the same output. Look at this output. And look at the same output here. This is one of the properties of hashes, which is called determinism. And it means that the output of a hash function doesn't change between runs. It's in fact the same mathematical process applied. These hash functions are also called one-way functions. Another important property of a hash function is that it's very easy to compute the hash from the given input, but infeasible to find out the original input from the resulting hash. Or, if you have the hash you are seeing right now, there is no way to find out what information, what word, file or packet has given that hash. Note that hashing is not encryption. There is no secret, no key in hashing.